Good morning, Shelly. Good morning, Shelly. Can you hear me? Okay, you can just ping on the chat window if you can hear me or not. Hey, Shelly, can you hear me?
Yes, I can.
Okay, sure. So, Shelly, we are just waiting for others to join in, and we'll be starting in the next 5 to 10 minutes. The first class of people might be facing some difficulties in joining in.
No problem.
Sure.
And by the way, it's Sally without the S, the H. It's Sally.
Oh, I'm so sorry. I'm so sorry.
Oh, it's not a big deal.
And actually, there are a lot of Indians with name of Shelly. So I need one of my good friends also. So I'm just in. But I'll remember that Sally, right?
it's yeah, that's fine.
Okay. Thanks for that. Thank you.
Hi, this is Padmini joined.
Hi, Padmini. How are you?
You're fine, doing good.
Good morning. Padmini will be joining. Will be starting in the next few minutes. So waiting for others to join in. I'm expecting
Oh, sure.
3 more people to join in, and then we'll be starting up. So today is the first session, so
Okay,
people might be facing little difficulty. So we'll wait for them.
okay. And this session, no, like Meeraj told that, may not be requiring the installation. This is only theoretical, right?
Yeah,
Because
Padmani, this
I'm
is
new to
Mirage.
iPad.
This is Mirage only. So,
Okay,
we'll not be requiring any laptops for next 3 classes at least. And
okay, fine.
from the fourth class, we'll be requiring the laptops. So don't worry
Oh,
about that
sure.
part.
Okay, then. Thank you so much.
Sure. By the time others joining in, it will be great if you can just introduce yourself so that I know your little background, and that will help me also to organize a session. So I'll hold over the mic to Sally first.
Okay. I'm actually in Corvallis, Oregon. I work for Hewlett Packard or HP. We're splitting up, so I'm on the HP side. And I just started a new job working with big data and Hadoop, and so was given the opportunity to take this class. I've been writing with Java for a long time and just need to know more about Hadoop, and so that's why I'm here.
Yeah, okay, that's great. And so technically, you know Java as a language, right?
Oh yeah.
That's good. Okay. And do you have any knowledge of SQL, any scripting language, anything like that?
Yes, I do.
Okay, that's good. Okay, sure. Hey Padmani, I'll hand it over to you.
Hi, I work for a bank in Canada, and pretty much also on data warehousing. I have like 12 plus of years experience, and my core experience in data warehousing is 8 years. Data load, and right now I'm just doing the role of a data analyst. So I thought that I can explore like big data. I have like knowledge on data warehousing tools, various tools, and SQL and all those stuff, but I have little knowledge on Java and .NET.
So Padmi, don't worry about that. I'll help you wherever Java knowledge is required, but for processing the data, when we'll be using Hive and Pig, it's all scripting and SQL kind of language, so you don't worry about those part.
Even if you guide me with like some materials related to
Definitely,
Java, then
definitely,
I
don't
prefer
worry.
to learn it actually. That's not a problem.
Sure, definitely, definitely. Don't worry about that. So indeed, 70 to 80% of my students do not know Java, and they are pretty good and doing good in the big data world. So don't worry about that part. I'll definitely guide you and help you on all those parts.
Oh, sure. Thank you so much.
So we'll wait 5 more minutes because today is the first class, and then we'll start.
Yeah, sure.
It's always hard on the first day.
Sorry?
It's always hard on the first day. Everyone's
Yeah,
trying to.
yeah. And some might be having early morning on the weekend, so yesterday night hangovers might not be over.
Yeah, I know I stayed up too late last night, but that's okay.
Okay. So I'll introduce myself and everyone join in. So that will be
Okay.
good for everyone. Sure. So anything else which you want to share or anything which you want to ask by the time others are joining in? Any
The only
doubts?
thing is like I would like to have more lab or class sessions. So no, we will have like a lot of practical knowledge actually.
Definitely, Padmani, you will have a lot of labs as well as you will be given a project. So practical part, I make, the thing is, I always request people to do hands-on rather than dumping them with the theoretical knowledge. So otherwise, that
Oh,
does not
sure.
make sense. That's my always a preference to so that you people learn up rather than just
Okay.
I dumping you with the PPTs and the session that
Okay.
you can read anywhere. So that does
Oh,
not
sure.
fulfill my objective.
Okay, sure.
Hi, Puneet.
Hi Miraj, how are you?
I'm good. How are you?
I'm doing good, thank you.
So, Puneet, I have Shali on the call, Padmini on the call, and they just introduced themselves. You can also introduce yourself to others.
Okay. Hi everyone. So this is Puneet and I work for one of the US based telco.
Puneet, I think you are a little
Uh,
far away from your mic. Could you be a bit closer to the mic?
Yeah, am I audible now?
Yeah, much better.
Okay. So what I was saying is that I work in US based
no, we
telco.
couldn't hear actually. That's okay.
I think, Puneet, you have to
Uh,
adjust your mic a little bit. Somewhat, you have to get near to your mic.
okay. So uh, am I audible now?
Okay, yeah, I can bear with that. You can go ahead.
Okay, so what I was saying is that I work for one of the US-based telco, and I want to learn this course, of course, big data and Hadoop. So yeah, pretty much.
Okay. So, and to add on, Puneet also is working on analytics related thing. So he's good at analytics part also. So definitely, Puneet, we'll try our best to help you out with the big data part. So we are just waiting for two more people to join, and then we'll be starting up.
Are we going to be covering anything like Spark or Yarn?
Yarn, yeah, definitely. Spark is totally a different concept. Spark is not related, not be covered in this session. That
Okay,
comes to real-time analytics. But Yarn, yeah, definitely, yes.
excellent. Thank you. I've got one more question. So how many weeks is this course?
Okay, so the course is approximately 25 hours, and I do not, commit hours. Indeed, I commit the course. So sometime it
Mm-hmm.
might extend a little bit, sometime it might be over in one or two less classes, but average is 25 hours. So based on your grasping knowledge, based on how you get the things. So that is approximately 25 hours, which it goes.
Okay.
So I think we can start. People might be joining in and they can join later on. So good morning, everyone. Good evening for the people who joined from India. So myself, Miraj, I am working as a big data architect for one of the leading organizations and have been working on big data from last 3 to 4 years, working in the industry from last 14 to 15 years and have taught a lot of people on big data and related stuff in last 2.5 years. So, and definitely I've implemented a lot of big data projects and have been architected different solutions for different clients, including some of the big retails across the world. And I'll definitely try my best to help you with all your technical questions related to big data and will help out all the possible things. And I can see someone else joined. Okay, he might be joining in. So I'll share my screen. Please let me know if you can see my screen. So you can quickly ping yes or no on the chat window if you can see my screen. That will help up.
Yeah, I can see Apache Hadoop.
Sure, sure. Sally also says she can see. Padmani also can see. Hey, someone
Yeah,
joined.
I
I can
can
see
see.
someone with the name of Android.
Yeah, this is Raja
Hi, Raja.
from Hungary.
Hi, Raja.
Yeah.
Hey, Raja. So
Yeah.
we are just starting up. Everyone was just introducing themselves. Could you
Uh-huh.
please introduce yourself to others and to me?
Yeah. I am Raja. I am working from Hungary, so to Swiss Re insurance client as a database administrator. So I just thought of interesting, so many people talking about big data, so and Hadoop concepts. So I thought of so joining and make use of this session.
Sure,
So
definitely.
that's my yeah.
Sure.
So
So
may you know about you and
yes,
something
definitely.
else?
So I was just introducing myself and I'll just repeat up. So Raja, myself, Miraj. I am working as a big data technical architect for one of the leading organizations in India and have been teaching people on big data from last 2.5 to 3 years. Have worked on a lot of big data projects in last 4 or 5 years and majorly into this industry, working in the industry from last 14 to 15 years and have extensive knowledge of big data, Java, and related stuff. And I'm teaching people on big data and related stuff from 2 to 2.5 years, from last 2 to 2.5 years. And I'll be taking all your big data classes, and I'll be your trainer in this session.
Yeah.
So
Yeah,
thanks
thanks,
for
Miraj.
Sure. So thanks everyone for your introduction. Others might be joining in later on, so I think we can start up. And if anyone can't see my screen, just ping me on the chat window so that I can just help you out. So good morning, good evening, and good afternoon to all of you. So let me introduce ourselves before going ahead. So we are a Design Pathshala family. We are teaching people across the world, and we are teaching people in a lot of cutting edge technologies. Most of our courses you might have seen on our website. So there are a lot of courses on different cutting edge technologies, and we all of our trainers are working in the industry so that they can help you with the real thing which is happening in the industry, and they can connect you with the real life examples and experience. That is our basic motto, so that you people can implement the things what you learn in the classes. So that's all. Learn and apply to your work. So this is what we'll be covering up in the session. Let me explain you a little bit what is this all course and what we'll be covering up. And if you have any questions, just ask me up. So we'll be starting up. Oops, sorry. We'll be starting up with motivation for Hadoop. What exactly is Hadoop? What is big data? And then the basic concepts of Hadoop, how the HDFS file system and how the data is basically stored into Hadoop-based file system. Thereon, we'll be moving on to MapReduce and advanced MapReduce related algorithms. So for those who don't understand Java, don't worry about the complexity, but understand the concept. So this is the concept which we'll be using on in the later technologies, and that will help you to understand the data processing. So MapReduce, and we'll look into advanced MapReduce algorithms. Thereon, we'll be moving on to Pig and Hive. So Pig and Hive are used in the real industry for doing the data processing. Although MapReduce is there, but people do not use MapReduce due to different reasons. We'll be talking about all of those things when we'll be talking about Pig and Hive. So people prefer using Hive. Hive is a kind of SQL language where you can write SQL kind of queries, and at the back end that triggers your MapReduce code and then do the data processing. Pig is a scripting language wherein you can write scripts. It's a very, very easy scripting language. It won't take more than 2 hours for you to understand the thing once you understand the concept behind what we'll be teaching in these classes. So these are the two things which are used in the industry and across the industry to do your real data processing. But once you understand the concepts of Hadoop and the architecture of MapReduce, these things would be easier. It's a kind of child job for you. And thereon we'll be moving on to Scoop. Scoops helps you to push in the data and push out the data from your SDFS file system to your RDBMS world. So this is basically used to get in the data, the enormous amount of data which you process. Oozie is a workflow. So with the help of Oozie, you can stitch everything together, the MapReduce code, the Pig, Hive, you can create your workflows, and then you can trigger your workflows on a daily basis or a predefined frequency. Thereon, we'll be looking at just some basics of how you visualize the data or how you do a real analytics on the data. This is not intended for this session, but I always take a class on this thing so that you get a real feeling how you visualize the data which you have processed in the Hadoop system. And at the end, we'll be doing a final project, which I'll be giving to you people. You have to implement it. Then we'll be discussing this project. And once you complete this project, submit this project. This project will be analyzed by me and one more people. And based on that, you'll be given certifications from us. Any questions on this course content? Anything which you want to ask? Anything which you want to tweak? Anything?
Yeah, Miraj, maybe
Actually,
I'm working on this technology, but I'm just learning. So how I can do the project, because
Okay. Okay. Okay, so
Neeraj, like those details.
just a minute. Let me answer this question, and I'll come back to you, Padmini. Just give me a minute.
Oh, sure.
Raja, for your question, I'll be sharing you the virtualized environment which you would be setting up on your laptop. So after first two classes, I'll be helping out you how to set up all those things. I'll be sharing you all the software which you
Okay.
can install on your laptop, the virtual environment, wherein you would be learning. So after each and every hour, after covering each and every part of our course,
Mm-hmm.
so after covering each and every topic on our course, I'll be giving you
Mm-hmm.
a problem statements, few problem statements related to that part, and you will be implementing that
Oh.
thing. So we'll be discussing that thing in the class. Wherever you face problems, I'll be giving you the control
Uh-huh.
to share your screen so that you can show me what is the problem you're getting, what is the error you're getting, and this is how you'll be proceeding
Okay.
up. And you will be using the same virtualized environment to implement your project, and you have to just submit me the code part. Does that
Okay,
make
okay.
sense?
Why? Because I do not have laptop. Yeah, yeah, really makes sense. And but I do not have laptop, but I have iPad, so I'm using
Raja,
iPad to.
Raja, you would be requiring a laptop for the practical sessions.
Mm-hmm.
So for the
Okay,
first three
okay,
classes, you won't be requiring it, but after the three classes, when we'll be coming on to the technical part, at that time, I request you to
uh-huh.
carry a laptop for the class.
Okay, okay. Then I will request my friend to take that one.
Sure, sure, sure. Yeah.
Yeah. All right. Thanks for the information. So,
So yeah, definitely because you
uh,
have to do the practical. So for that, you can't do on iPad. It's difficult to type any a single command on iPad. So iPad won't help
okay,
you.
okay. Yeah.
Sure,
All right.
sure.
Thank you, Miraj.
Thank you. Yeah, Padmani, you had some question?
Yeah, actually, I saw the course content like which mentions like HDF is design and architecture concepts, and HDF is using command line Java APIs.
Yeah.
But here only it talks about the
Okay.
basic
Okay. Okay.
concept.
So yeah, we'll be covering all those things in this part. So SDFS,
Oh, okay.
the SDFS, how you interact with the SDFS, the command line, all those things I'll be covering up in this part.
Oh, sure. Thank you.
Sure. Anyone else has any questions? Sure. Okay. So, okay, before I move on to how data comes up, I hope no one has any questions. So let me introduce, let me talk about one thing. So I hope everyone would have heard about Target, one of the big retail stores in Australia and in US. So our angry father entered a Target store, shouting on his full voice to the manager, "How dare you can send me How dare you can send to my daughter the maternity discount coupons? She's just 18 years old." The manager looked at the coupons. He apologized, "Sir, by mistake, we would have sent those maternity coupons or maternity discount coupons to your daughter. I really apologize to you. Please be quiet, and I'll try my best to remove this thing from our database." 2 weeks after, this is when the father called the same. I request everyone to please go on mute, and once you're required to speak, I'll unmute you. So I'll mute everyone, and once you're required to speak, I'll unmute you from here, and that will help up everyone. So I muted everyone. So 2 weeks later, the same angry father called the store manager, apologized him. "Sir, I'm extremely sorry. Target knew before I knew that my daughter is pregnant, and how Target knew is based on the shopping what her daughter was doing from the Target store. They predicted that she might be pregnant, and she was pregnant, and she was in her second trimester and moving to the third trimester. So this is what is done in this industry. People know what is happening in the or what is going to happen just with the help of data. So data has all the power. People are marketing only on the data. People are minting only on the data, and that's power which people are getting is with the help of data processing, which is happening in the systems like big data. Netflix knows which movie you might like before your friend even tell you that this is a movie which you might be liking up. Google knows there's a flu in some particular parts of US or some particular parts of the world because people start, querying on the Google. There was earthquake in Delhi NCR and Nepal. Google knew it first that there is an earthquake because people started searching on the Google before even the government agencies knew it. a boy who has a single page on Facebook, nowhere else he existed in the internet, requested Facebook, please send me what all data you have by my name. Facebook sent him 10,000 page of PDF. This is the data which we have about your activity across the internet. So this is the kind of data which people are sitting up with in the industry, and with the help of these data, people are minting up the things. Boeing, I'll come to all those stats later on, but I just wanted to tell you a few of the things, how people are using the big or enormous amount of data on which they are setting up with. So if you remember around 15 years down the line or 10 years down the line, there were computer operators who used to sit on the PC, enter some data, and our PCs has my first PC has I think 255 MB hard disk. Nowadays 16 GB RAM is insufficient for me. So those were the days where people were just entering some data on their PCs, and we were good enough with that. And if you can recall this picture, we used to have a floppy disk of 2.3 MB, 3.5 MB kind of things, and that was much more than sufficient for us to carry and store our data, right? But the world is changing. The rate at which data is coming to our systems is enormous. It's not only the computer operators or people like me or you just sit on and just insert some data into the systems. Users across the world are inserting enormous amount of data into the World Wide Web or at different places, and this data is growing at an enormous rate. Be it Facebook, be it Twitter, be it LinkedIn, be it anything, there's an enormous amount of data which is generated each and every second of your click. And it's not only the user generated data which is getting generated in this industry. There's a lot of other data which is getting generated, and data itself has become a problem to us. And to solve that problem, there's something called big data. So I'll be talking about what is big data. But before that, let me talk about a few more places from where data is coming up. So can anyone guess what this picture would be doing over here? Sally says weather, yes, but how could you relate it to the big data word? Yeah, Sally, you can go ahead and speak.
Okay. So everyone's got a cell phone. Everyone can see the weather. You're constantly getting piped what the weather is going to be, what the forecast is. There's a huge amount of data of what that is, what's going on everywhere. And you can find out, at any time what the weather is any place.
Yes, and to predict that, there's an enormous amount of data which is generated by the satellites across the globe to predict what is the weather. And to predict what is the weather at 2 p.m. today at New Jersey, the data of last 20 years or 50 years is processed to predict out where would be the clouds at 2 p.m. in New Jersey today. So the data which is generated from satellites is enormous, and we have to process that data to come up with these facts and figures. What will be the weather today at so and so time? There's one more picture popping up over here. Can you guess what it's doing over here? No, not the traffic not the traffic control. No, no guesses. Okay, so I hope everyone would have heard the black box of an aeroplane. So a normal Boeing 357 generates 10 GB of data every 30 minutes per engine. 10 GB data every 30 minutes per engine. if I'm flying from New Jersey to New Delhi, you can think of what is the amount of data which is generated in my black box. And a normal Boeing has normally 4 engines, so approximately 40 GB of data per flight per 30 minutes, and approximately 80 GB of data per hour. So if I get a black box of some of the mysteriously missing flights in the recent past, like Malaysian airline flight, you can think of what is the amount of data which I have to process out just to figure out where this flight would have lost or what would have happened wrong with the flight. So these are the kind of machine generated data which is getting inserted into our systems each day. Hospitals. There's an enormous amount of data which is used, generated from your different machines in the hospitals, be it X-ray machines, be it your sonography machines, be it of any machines. This data is used to predict your diseases, what can happen to you, to not only to do the research, but to predict what could happen to you in the future, and used by insurance agencies to give you the correct insurance quotes. And I hope everyone can guess what I'm showing in this picture. Do anyone want to tell? No guesses. Padmani, Raja, Puneet. Retail store, yes. Padmani says retail store, yes. So the data which is generated by these retail stores is again enormous. Walmart generating more than 1 million transactions per hour. So I'll give you one example which I always give in my all of the classes. There was one of the fruit vendor who used to visit my society, and I normally used to buy fruits with him. And then after a few days, I don't say a few days, after some time, he stopped visiting the society, and I also forgot. I started buying fruits from a nearby vendor. Um, Around 7, 8 months back, I shifted to another house, and I saw the same fruit vendor over there. I asked him, "Hey man, how you shifted from that place to here? Why you are now selling fruits over here?" He told me people over here carry big cars. People are carrying Audis and Bugs over here, and houses sizes are big. House sizes are big, so the spending power over here is more. People do not bargain me much, and they buy more fruits to me. So his market was limited. His sales area or number of SKUs or number of commodities which he sold was limited. So he himself was able to do analytics prediction on the data and was able to figure out what is the best market for him, where to sell the fruits. But if Walmart has to do those kind of predictions, do those kind of analytics on the data, you can think of what is the kind of processing they require at the back end. They are generating just 1 million transactions from these kind of retail stores, then online transactions and n number of things. So these people also always come up with interesting, correlations. Like last year, Walmart came with a correlation between sales and hurricane. So wherever is hurricane in USA, whenever there is a hurricane in any part of USA, strawberry Pop Tart sales increases up. Who cares why it increases up? But it increases up, and Walmart uses that data. They just supply up, increase the supply of Pop Tarts to those corresponding store where they predict there's a hurricane going to come up, and that's increase their sales. It does not matter to me why it increases or why the sales increases for a particular commodity. What matters to me is how can I increase my revenue, and that all can be done with the help of data processing, which is being done in this industry. So let's talk about the 3 V's of big data: volume, velocity, and variety. Volume, as I'm talking out till now, there's an enormous amount of data on which we are setting up with today. If we just look at World Wide Web, these figures might be a little old, so I do not claim these figures, but I just wanted to give you little insight what kind of data on which we are setting up with the volume, the first V of big data. World Wide Web itself is sitting up with more than 3 gigabytes of data, and gigabyte is 2 to the power 10. Library of Congress sitting up with more than 300 TBs of data. Facebook 30 plus petabytes of data. Walmart, just in their data warehouse. I'm not talking about their database systems and other systems. Just in their data warehouse, they are setting up with more than 2.5 petabytes of data. eBay setting up with 10 plus petabytes of data in their just in their data warehouse. And if they have to come up with these kind of analytics, facts and figures, you can think of what is the processing power which is required. We can't handle them in our traditional relational systems. And the second problem with this word is it's not only the volume of data on which we are setting up with, but the velocity at which this data is increasing. So if you look at YouTube, at every minute there are 48 hours of new videos which are uploaded to YouTube. So if I have to apply YouTube policies on the uploaded videos, I have to process the videos at a power of more than 48 hours contained in less than a minute. Then only I can apply the YouTube licenses and different things on or the policies on the on the videos. There are more than 571 websites created each minute. Facebook is generating more than 500 TB of data per day. Twitter, 175 million tweets per day. Walmart, I just stated 1 plus million transactions per hour. And this is not only the problem. The next biggest problem is the rate at which this velocity is increasing. That is the acceleration of this velocity. So the rate at which this velocity or the data growth is increasing is again 40. Basically, if I compare the rate at which this rate is increasing or the velocity is increasing from 2009 to 2020, the rate would be 44 times higher. So this is not the velocity, but the acceleration of this data growth is again a bigger challenge to us. And if you have to handle this data, the traditional systems or vertical scaling is not the solution. And the third most problem is the variety of the data. Everyone knows what is a vertical scaling, what is horizontal scaling. Shelly says yes. Is there anyone who does not know what is vertical, what is horizontal scaling? If you can just keep on pinging yes or no on the chat window, that will be great help so that I can know that you're getting up the things. And okay, Puni says no. Okay, so Shelly, do you want to talk? Sorry, Sally. Shelly, do you want to talk what is vertical and what is horizontal scaling? So I'll unmute you. I think you are no.
No, why don't you go ahead?
So I just wanted to hear from you, and then I'll definitely go ahead. Okay, I'll go ahead. So when we scale the systems, say I have a laptop with 4 GB RAM, and I want to run something on my laptop, and that is not sufficient. I want to play some games, and with the scarcity of RAM, I can't play the game. I'll increase the RAM from 4 GB to 8 GB, and then I can play some games which were RAM scarce. So that is a vertical scaling. I'm increasing my resources vertically on the same servers. What is horizontal scaling? To do the data processing, I add systems parallelly in my cluster. So if this is one of my server, and this server is not sufficient to process my data or process my request, I'll add one more server parallel to it, and half of the requests will be directed to here, half of the requests will be directed to here. So this is what we call horizontal scale. We scale the systems horizontally, and the beauty about horizontal scaling is we can add as much nodes or as much resources to our cloud or to our system as much as we want. But the problem with the vertical scaling is there's a limit by which I can add the infrastructure to my existing servers. I can add max 16 GB, 32 GB RAM to my laptop, similar to the servers. So there's always a limit to vertical scaling, and vertical scaling is always a costly effort. So we'll talk about. So Raja says he's not able to unmute himself. I'll just help him out. So Raja, you are on mute now, but I think your mic is disabled. Please check your mic. You are on mute now. So yeah. So, but just let me complete and then I'll come back to you. So the vertical scaling is always costly and there's a limit to vertical scaling.
Okay.
You can add the infrastructure only to a limit on a particular servers or to a particular node, but there's always, you can add number of resources to your infrastructure, to your cloud and horizontally, and that there's no limit to horizontal scaling onto your cluster. So we'll talk about this thing again in the next few slides, but you should be knowing what is vertical and what is horizontal scaling because this is all about data processing in the big data world. So Radhi, you have any question?
Yeah. Are you able to hear me?
Yes, I can hear you.
Okay. So you are talking about cloud environment, right? Here, so just I would like to correlate with my infrastructure where I'm working. So here, all the databases in non-cloud environment, so it is all limited. So maybe some terabytes of data. So with the SAN storage, so. So that means you are indirectly encouraging us to get into the cloud, or how it will
So again, it depends on the systems on which you are setting up with. What is the kind of things which you're running over there. If you are running traditional database systems like Oracle, MySQL kind of thing, there's a limit again to vertical scaling. Although nowadays they started supporting horizontal scaling, but again they do not have such kind of in architecture what Hadoop gives to you. So, so again, that will depend on. I'm not sure what is your systems, what you are running up. So I can't comment exactly on your question, but definitely horizontal scaling is always a better solution as compared to vertical scaling, and that's what's happening in the industry from last 5-6 years. Vertical scaling is always a costly effort, and
Okay.
you can't. There's a limit. A machine can be scaled up.
Oh.
So, so the third problem with the data is does that answer your question right? I
Yeah.
think that is
Because
partly answered, but let's just understand the SDFS concept, and I can again recall your question, and then you would
yes.
get more insight.
Why I am asking is, because I am working as a DBA, so in SQL Server, it is definitely, I think, as per your definition, it will come under vertical scaling.
Okay. So okay, Raja, what I'll do is let's park a question for two of my classes. And let's
Okay.
again take a question on the next week. And by that time, you yourself would be answering your question.
Oh, okay. All right.
Okay.
That will be great.
Okay. So just try to understand the system and then let's come back to your question.
Okay.
Okay. So the third major problem with the data is the variety of the data. The kind of data on which we have to process. So the more unstructured data is, the more complex my algorithms would be to process it. And the more complex my algorithm would be, the more CPU hungry, the more RAM hungry they would be. So the structured data, semi-structured, JSONs, XMLs, unstructured data, text, emails, videos, audios. This is the different kind of data which you have to process up to look into the data, to do analytics on the data. So these are the three problems with the data, and with the help of big data, we try to resolve these things. The algorithms would be yours to process the data, but the infrastructure or um, the processing power would be given by the big data systems to process your data. How that is done, we'll be looking into the next slides. So before we move on to these, before we move on to that part, let me talk a few more things, few more interesting things to you before we really move on to what is SDFS, what is big data, and things like that. So how companies are using big data to mint money? I gave you a few examples, but let's see a few more things. How companies are really, using big data related system. Each and every company, you open website of any company, any IT company, somewhere left hand side or right hand side, there will be a separate tab these days, big data analytics. Everyone is hiring on big data. So people are using the data on which they are sitting of it, trying to mint money with the data on which they are sitting of it, and everything, all of that thing is possible with the help of processing power which big data gives to them. So predict what customer wants before they ask for it. You log into LinkedIn. LinkedIn will suggest you friends uh, before you even search for a friend. You log into Facebook. Facebook will suggest you the different friends before you search for them. So they predict what you are looking for. You log into Amazon website based on a previous Google searches. They will suggest you the product you might be looking for. You search for any damn product on any of the e-retail website. Go to any other website across the World Wide Web, somewhere on the left hand side or the right hand side or on the top, and there's an ad or advertisement pops up for the same product, indeed with the same specifications. So at the back end, there's an enormous amount of data processing which happens up to predict all these things and to show you the ads which are relevant to you. So predict what exactly you want before you even ask for it, and that happens with the help of enormous processing power which these systems gives. Marketing campaigns. People are doing targeted marketing these days. If I talk about Luxottica, one of the premium brands, they target customers, and they only target HNIs based, and before targeting HNI, they process their previous historical profiles, and based on their historical profiles, they target the customers with a corresponding product what they might be looking for. Improve customer service. People are trying their best to improve their customer service based on the data which they have, based on the kind of data which is generated in the system from the previous interaction with the customers. If I give you an example of one of the most interesting airline example, there's an airline called Delta Airlines. What they've came up with an app called Track My Bag app. So all of you should have would have traveled international, I hope. So the most problem or the most troublesome thing while traveling international is your baggage probably get lost. And if your flight is hopping flight, the high probability that your bag might have, dropped on the hopping station or somewhere here or there. So these data airlines, they came up with an app, Track My Bag app. All you have to do is just click a snap on the bag, the tag which is there on the bag, and then your bag is tracked on the app. So although your bag might be misplaced on the hopping station, but when you can see your bag is lying at so and so location, you might not be calling up airline again and again. You might not be troublesome where my bag is, and you would get the exact time when your bag would be reaching to you. So people are trying their best how to improve the customer service with the data which they have. Fraud detection, highly used in the banking industry. Uh, Anti-money laundering is a product which is mandatory for each and every bank to implement, and they have to each and every bank have to generate SAR reports at the end of quarter, at the end of month, based on the government norms. They have to submit these SAR reports, that is predicted fraud behaviors in their transactions, so that government can take correct actions on those reports. And if bank fails to do that, they are charged heavily, they are fined heavily. So what these bank do is they predict what is the kind of behavior you have on your accounts. Say each month a salary of 10,000 USD comes to my account. One month $1 million comes to my account, and next they just vanish away. So in such a scenario, bank will detect there's something fishy in your account, and such kind of activity will be propped up as a SAR report, and that will be going to your federal government. So all of these things happen at the back end, and it's not only the account related things, the stock trading, mutual fund trading, everything. They detect your past behaviors, and based on that they come up with these reports, and this all is done with the anti-money laundering activities which bank does. So there's an enormous amount of data which requires to be processed up to come up with these reports, and this everything happens with the help of big data only. I remember my first project was anti-money laundering only, and at that time it took us more than 1 or 2 days, sometimes just to run a query for a particular customer on the servers to come up with their risk factors. But nowadays everything is just done in few seconds. I still remember one of the examples for a bank where I was working up. I was summing up the transactions for one whole day, and one of my testing friend, he also summed up the transaction for the whole day, and both of us saw a difference of half a million Singapore dollars in one day transaction. And half an hour later, we figured out the precision which my testing friend was using was 2-digit precision, and the precision which I was using in summing up was 4-digit precision. And that gave a difference of half a million Singapore dollars in one day transaction. And if I have to do these kind of activities on those transactions, you can think of what is the processing power required at the backend. Getting customer excited about their own data, identifying customer pains and solve them. People try to figure out you on social media network and social graph analysis. This is a place where the big data is used enormously, and each and every company is very much concerned about their social graph, how they are looking on the social graphs, be it Facebook, be it Twitter, be it anything, and they're monitoring it at great instant. So Flipkart is one of the major leading e-retailer in India. I ordered one of the product from them. I tried to call their customer care when the product reached to me as a faulty product. No one listened over there. I posted one comment on the Facebook page. Within 30 minutes, I got a call back from Flipkart stating, "Sir, please remove the comment from the Facebook page. We'll replace your product in by tomorrow." So in 30 minutes, they not only processed the Facebook comments, where their name was coming up, they predicted who is the customer, they predicted what is, they figured out what is the product which I would order from them, and everything was done in just 30 minutes. And it's not only the companies who are using the big data, it's the governments, the US government, the Obama government gave a $200 million budget for different government departments to use big data. Department of Defense, Geological Survey, Department of Energy, all of these departments now in US are using big data at the back end to do the data processing. Any questions over here? Anything which you want to ask? Does this sound a little bit interesting, exciting? Puneet says good. So I can see one more person joined in. Chris, hey Chris, welcome. We started now a long back, but I just saw you. So yeah, you can introduce yourself. Everyone has introduced themselves. You joined a little late, so if you want to introduce yourself, you can just go ahead. By the time anyone has any questions, it's okay, good. Okay, I assume a yes from everyone. And Chris looks like he's dialed in from phone, and he might be. So these all things I have talked in my previous slides. Facebook, LinkedIn, the kind of data which they have, and they are using it for processing and coming up with different facts and figures. Human genome, which took 10 years to process, nowadays can be done in just 7 days, and it's all because of the processing power which we get by using different technologies, including big data. Okay, so this is a big data market. This is a slide which I have copied from Webicon. The graph of 2009, 10, and 11 is not invisible over here. It's the graph was so small that is not visible over here. But you can see the market is expected to be 53 US billion dollars by 2017. It's increasing at a rate of 1,000+%. This is a rate at which this market is growing up, and it's expected to be a huge market in next few years. So these are the different job options or job opportunities which people look in this market. I'll quickly go through them. You can read them. Hadoop architect is a kind of option which people go up with. based on their work-ex, and there you basically you do the designing of the big data systems, you do a solution designing, how your data would be coming up, what you would be using to process the data, how your system would be looking like, the number of nodes which you would be having in your cluster, and things like that. Developer, almost similar, overlapping roles, but more on the development side, writing high scripts, big scripts, UG jobs, and things like that. Data scientist is a blend of big data and analytical tools like R, Tableau, and things like that. So that is a blend of big data as well as analytical tools. So this course will not make you a data scientist, but you can target any one of them. And Hadoop administrator is a totally different area where people do the administration of the hardware. So here we'll not be talking about installation and things like that. This will be a developer course or an architect kind of course where I'll be talking about how to develop the things, how to architect the things, how to design the systems. Yes, Chris, I think you have dialed in from phone and your phone is showing a mute from here. Let me try to unmute you. No, I can't unmute you because you have dialed in from your phone and not used the audio which is provided by the by GoToMeeting, and I can't hear you. Indeed, no one can hear you. You can ping on the chat window. I'll definitely read it for you, and you can just type in your introduction also over here, and I'll read it for you. There's a big data job market. There's no okay, only Puneet is from India from here, and rest are from different geographies. There's a kind of big data jobs in US. This is what I got from PayScale. This is the kind of average salaries which are paid in the big data related field in US. Nowadays, this slide is outdated. Nowadays, each and every company is working on big data and related stuff, and I won't say it's just the Amazon or Yahoo or Netflix. Each and every company is nowadays working on big data and related stuff and hiring a lot. Okay, so before moving on to what is Hadoop, how the history of Hadoop, any questions till now? Anything which you want to ask? Okay, Shali says good, looks good. So others can also say, okay, Puneet also says good. I'll assume a good from others, myself. So let's talk about how Hadoop came in picture. What is the history behind Hadoop? So there's I hope everyone would have heard about Apache. So there's a product called Lucene which was running up in Apache, which is a text indexing engine. So that basically index your text and that helps you to search your search different things in the text. That product was headed by a person called Doc Cutting. And inside the same project, Apache started one more sub project called Nutch. And Nutch was a web crawling engine which basically crawls the webs and find out the other website links to a web and store them in files and doing a web crawling basically. So they were trying to do the web crawl, and you with the help of Lucene, they were trying to index them and were trying to create something what Google is doing. So dog cutting started Nudge as a subproduct in under Lucene, and as per the instructions from the higher teams, higher authorities, and soon he told that the vertical scaling of the systems is not possible because the rate at which we'll be crawling the data from the website would be too high and will not be able to run Nudge or do a web crawling of the web of www for more than 2 months on our current infrastructure. So he came out with another infrastructure related requirements, and just the maintenance of that infrastructure in 2004 was more than $500,000 per month. But that was an ambitious project from Apache. They gave a go ahead, and dog cutting started crawling the web, and they tried Nutch and Lucene as a blend. But pretty soon they were not able to do a vertical scaling of the system. They were not able to scale their systems, and their product was stopped, or their project was stopped. At the same time, Google came up with a white paper, Google File System, and Google MapReduce. This dog cutting read that and created a similar thing, what we call HDFS, Hadoop-based file system, and use the same thing to implement over here. And he was able to do a horizontal scaling of his systems, and the product was running smooth after that. So this is a brief history about how Hadoop came in picture and who is the father. So dog cutting is said to be the father of Hadoop, and most of the Hadoop related development happened in Apache, and it's an open source from Apache. Later on, down the line, 2 years down the line, dog cutting was hired by Yahoo, and I hope you can easily guess why why he was hired from Yahoo, because Yahoo and Google are biggest rivals. And then a lot of development for Hadoop and related stuff happened in Yahoo. Pig is the thing which was developed in Yahoo only. So, but everything is open source, and Apache has its own flavors of everything, and everything is open source from Apache, and we'll be looking at everything open source which is used in the industry. So let me talk about one simple problem. I want everyone to answer this question, and just ping on the chat window. What do you think is is an answer to this problem statement? So this is a machine which has 1 TB of data in its hard disk. The hard disk has normal 4 IO operations, so it's just normal to your hard disk which you have in your laptops or desktops, and 100 Mbps is the speed of each IO operation. So this is a normal SATA hard disk which I'm talking about, which is lying in this machine, which is visible over here. And I'm sitting up with 1 TB data in this machine, and I have 4 IO operations on my hard disk, which is normally there on your PCs also, and each IO operation is 100 Mbps speed. I just want to read the data from this machine. Can you do a quick mathematical calculations? How much time do you think I would be requiring up just to read 1 TB of data from this machine? Just a quick mathematical calculation, how much time I would be requiring up to read 1 TB data from this machine where I have 4 IO operations and 100 Mbps is the speed of each IO operation. I request everyone to just ping me any answer. So Puneet, I don't want to look at the calculation. Please give me an answer in minutes or hours or seconds. I prefer if you can give in minutes. So Puneet send me a calculation. I don't have a calculator in front of me. You can just give me an approximate answer. So Puneet says 2,500 seconds. What about others? Chris, Padmani, Sally, Raja. So Puneet says approximately 41 minutes. Sally says 5,000 seconds. That comes to Sally says approximately 83 minutes. Okay, Raja said 4,000 seconds. Approximately 66 minutes. So Raja says 66 minutes. Chris, Padmini, just a guess. Chris says once 10, 100,000, 10, 100,000 million, 10 million, 20 million seconds. Okay. Chris says 20 million seconds. I can't calculate that to minutes or days. Okay. Padmini, I'm just waiting for your answer. Again, looks like she's away or something. Okay, so it takes approximately 45 minutes. I think Puneet gave the almost correct answer. So it takes approximately 45 minutes, or to be precise, I think 42 or 43 minutes, just to read 1 terabyte of data from my machine. Just to read data from my machine. Now, this would make be more interesting when I'll be switching on to next slide, but just remember this will take 45 minutes just to read 1 terabyte of data from my machine. So there's something called terabyte sort benchmark in the Hadoop industry. So the previous record was from Google, where they read 1 terabyte of data, processed it, sorted that data, and reinserted that same data into the cluster in 297 seconds. And that 1 terabyte benchmark was broken by Yahoo after 6 months from Google in July 2008. And they not only read the data, they sorted that data and reinserted that sorted data again to the hard disks in 209 seconds. So that's approximately 2 or 3 minutes. 209 seconds comes to approximately 3.5 minutes. So in 3.5 minutes, they not only read the data, they processed the data and reinserted the data. But just to read the data from my normal hard disk, it takes me 45 minutes. And what they use at the backend is a cluster with 910 nodes with 8 GB RAM per node and quad-core processors. So it's a normal as your laptop configurations, but they had used 910 nodes in a cluster to do this whole processing. And this is the power of horizontal scaling. So they horizontally scaled their cluster to 910 nodes, and they were achieved to do this in just 209 seconds, what we can do on a single machine in 45 minutes. So does that answer your questions? What is the power of horizontal scaling? And Chris, you joined late. We discussed about horizontal scaling and vertical scaling. If you have doubt about horizontal and vertical scaling, just ping me up right away. I'll help you out. So now what I did is, rather than reading that data from a single machine, I distribute that data to 10 machines. And now I have to read that data. Now I hope everyone can guess how much time I would be requiring just to read the data. 4.5 minutes. So by doing a division of my data to 10 machines connected over a network, or what we call cloud or network of machines, I can reduce the reading time to 4.5 minutes. And if I have to process that data locally on those machines, I can again use the processing power of 10 machines rather than one machine, and I can do a parallel processing across 10 nodes. And this is the beauty of horizontally scaling your systems and doing a faster processing. So this is the first thing, or the first advantage what is used by Hadoop as an infrastructure. At the back end, we have n number of nodes connected to a cluster, and the data processing happens locally on the node. So your data lies on the node. It's just the logic which which you want to run on the data that flies over the network, and that logic runs on the corresponding node where your data is lying, and only the output of your logic comes over the network. We'll look into that part in detail in the next few slides. But this is how I achieve a faster processing in my clusters with the help of HDFS or big data. Any questions over here? The power of horizontal scaling. Okay, I'll assume no. Next thing, when my data is distributed across the cluster, I can't, remember or recall where my data is. So there's something called distributed file system, or what we call HDFS, Hadoop distributed file system. So with the help of that, I know where my data is, and that is all managed by our infrastructure, or the Hadoop framework. We'll look into that part in some time when we're talking about name node and data nodes. But just to give you an idea what happens at the back end. So say these are the machines on which my data is stored. One machine is storing my design Pathshala project related stuff. One machine is storing my design Pathshala software related stuff. One machine is storing my website related stuff, and so on. But now uh, I as a person can't remember what is the IP address of machine where my images are stored, or where my project is stored. So what happens up is there's something called main node or master node in the cluster or in my environment, which maintains everything. All I have to do is whenever I require some data, I just interact with that guy, tell him I want so and so data. It's the responsibility of this guy to know where my data is. He will interact with that corresponding node and will get your data. So he will interact with that this node, and will get the data for me. So how that is happens, don't worry about that part. We'll be talking about that part. But this is how your files are distributed in the cluster, and you just interact with your master node, or what we call name node in the system, and that name node will return the data for you. So all I have to do is just give the namespace of the cluster and the corresponding file which I want to look at to my master node or to my main node in the cluster, and the rest of the thing is handled with the distributed architecture of the system. So my data is distributed on the cluster, and as my data is distributed on the cluster, I do a distributed processing of my data. So when I was talking about 1 TB salt, my data of 1 TB data was divided onto 10 machines. Each machine had approximately 100 MB or 110 MB of the data. And I send my sorting logic on each machine. I read 110 MB of my data on each machine, sorted the data locally over there, and persisted my data there itself. And because of that thing, I was easily able to achieve the best sort benchmark of just 3 minutes or 3.5 minutes on clusters with 910 nodes kind of thing. Does that make sense to everyone? What I've talked till now, what is distributed processing and how your data is distributed across the cluster. We'll be looking out we'll be looking out how that is done, how that is managed with the help of name node related architecture and data nodes. But does it make some sense to everyone? Sally says yes. Everyone else can also ping me yes or no, please, so that I can know you are there and getting up the things. Okay. Chris also said yes. Puneet also said yes. Okay. Okay. Raja also said yes. And okay. And Padmini, you are getting up the things. I did not heard anything yes, no from you from last. Not sure if she's there or not. Oh, she's there. Okay, sure. Okay. So let's look at the cluster sizes which people are using. We will look at the different facts and figures in our previous slides. What is the kind of data which is getting processed in this system, and what people are doing and how they are minting the money. Let's look at the back end, what is the kind of cluster which they are setting up with. Yahoo is setting up with approximately 42,000 nodes cluster as on July 2011. These are figures a little old, but I'm just giving you the kind of clusters on which people are setting up with, and with the help of them, that they are doing this kind of processing. LinkedIn setting up with more than 4,000 node cluster. Facebook, this data is older. I doubt this is a correct figure, but this is a figure which I had lastly from HadoopWizard.com. They are setting up with more than 1,000, approximately 15,000 node, 1,500 node cluster. And these are the kind of clusters which are used at the backend to do all that analytics on the data, which is shown to you, or which we talked about in our previous slides. So although I did not like formal definitions, and I'll try my best not to have formal definitions, but just bear with this definition over here. Hadoop is a framework for distributed processing of large data sets across cluster of commodity computers using simple programming model. So when I talk about commodity computers, let me go back to previous slides. So over here, if you can see the Yahoo, what Yahoo used to do that, sort of 1 terabyte data, they use the machines which were almost similar to your laptops or desktops. 8 GB RAM, quad-core processors kind of thing. So these are called commodity hardwares, cheap hardwares. So you connect cheap hardwares across the cluster to make your big clusters and achieve high processing powers across my clusters. So that is called commodity hardwares. And you'll be hearing lot many times the commodity hardware as a term from my mouth also, and from different people who are talking about Hadoop. So Hadoop is a framework of distributed processing of large datasets across clusters of commodity computers using simple programming model, what we call MapReduce. So MapReduce is a framework to process your data. I will be looking about what is MapReduce in some time. So do anyone want to talk about this definition? Want to explain this definition? Now I've explained almost each and every term in this definition in my previous slides. Do anyone want to explain it to me?
This is Sally.
Yes, Ali.
So distributed processing, so you're going to be taking the software is going to be distributed across all the different nodes along with the data. So the data will be distributed across the different nodes, the commodity hardware. The processing of the data will be distributed as well. And the cluster is that you will have a large number of actually the nodes or the separate machines. So it's distributing the data across a large number of nodes and doing the processing on those nodes.
Yes, I think that's perfectly fine. Everyone agrees with this? Okay, I assume yes. Okay, so this is the beauty of the cluster. We don't transfer the data over the network. We just transfer the logic, how to process the data to the node in my cluster where my data is lying. And as the logic will always be a few bytes or few MBs, logic will always be very less, but the data would be too large. So I always transfer my logic, what need to be applied on the data, and the output of logic would definitely be some facts and figures out of your data. So again, the transferring them over the network is again not a costly effort. So you just transfer the logic over the network to the node where your data is lying. You do a processing locally on that node and just transfer the outcome or the facts and figures of that data over the network, and which comes to you. And so what is big data? Big data is nothing, any data which is enormous enough and where I require high processing, or the data, when data itself becomes a problem, that data is called big data. So when you can't process your data with your traditional systems, your data itself become a bottleneck to you. That is called big data. That there's no predefined size. What is the size of data? What I should call big data? It's all depend on you, what is the kind of data you want to process when your data becomes bottleneck to you. So it could be the complexity of processing the data, it could be the data itself, or it could be a blend of both. So when the complexity to process the data or the combination of both becomes a problem to you, you come to big data as a solution. And what we'll be using for that is Apache Hadoop to do the processing. So MapReduce is a framework which is written to do the data processing. So MapReduce is, we'll be talking about MapReduce in very depth, but I'll just give you a little glimpse about what is MapReduce. So MapReduce try to break your problem, or try to break your data into key and value pairs. You define some keys on your data, you define some values on your data, and you do a processing with the help of keys and values. How that is done, don't worry about that part. We'll be talking about that part in our next Saturday class. So, and the framework, Hadoop as a framework is created in such a fashion that any kind of data, be it Be it structured data, be it semi-structured data, be it unstructured data, whatever kind of data you can fit in into that Hadoop or what we call HDFS as a file system. So the system is designed in such a fashion you can fit any of these kind of data over there, be it totally unstructured, be it structured, be it semi-structured. Okay, so this slide makes sense to everyone, right? Okay, so what makes it especially useful? Scalable. Whenever I require large processing power, I can just keep on adding nodes to my cluster and my system is scalable. So when I write a program I write a program or create a software, first question my manager asks me is, if the customer load increases, how could I scale? What I should do? Where I should tweak the code to make it more scalable? When you are using HDFS, you will be writing a single line of program or single line of code. Your code will remain same whatsoever is the data size. At the backend, our system would be scalable. We'll be adding up the clusters. We'll be adding up the nodes to the cluster, and your data would be processed across the network. And you might have heard a term called elastic clusters from Amazon. So the nodes are added to the cluster on the fly when you require the processing. And later on, when the processing is done, the cluster is shrinked up. So on the Christmas times, Amazon cluster sizes increases more than 10 folds. And after 1st of January, they again shrinks up. So they save the cost of infrastructure and the clusters are scalable, elastic. Economical, as I'm using the commodity hardwares to do the data processing and adding the nodes, those are very cheap. If I have to go to laptop, buy a laptop, if I have to go to market, buy a laptop with say 32 GB RAM, I might be paying more than 1000 USDs. Or even if I go to market, buy a slim laptop with 16 GB RAM and good configuration, I would be definitely paying more than 100 USDs. Oh, sorry, 800 USDs. But if I go to market, buy a laptop with 4 GB RAM and just two CPUs, that might be available in 150 or 200 USDs. So I can buy 4 laptops, total again 16 GB, but those are much cheaper as compared to a single laptop of 16 GB. So the vertical scaling is always buying or doing a vertical scaling of a cluster is always a costlier thing, but adding or using commodity hardwares is pretty cheaper. Efficient, because your data is processed locally where your data is lying, your data is distributed, your processing is distributed, the infrastructure is very efficient and reliable. Can anyone guess what makes it reliable? Any guesses from anyone? What makes it reliable? Puni says backup. Um, backup. Multiple copy. Okay, Sally gave me a perfect answer. Multiple copies of data, multiple nodes, processing of the data. Yes. So when I copy some data into the cluster, my data there are always multiple copies of my data. By sorry, by default 3. So when I copy say a file X, that file there will be 3 copies of that file X which will be lying in my cluster, and that copy of file X would not always be lying on a single node. That would be lying on 3 different nodes in my cluster. So if I say I inserted a file F in my cluster, that might be lying in node 1, node 5. And that file is divided into blocks. We'll be talking about that in some time. And say node 6. So a same copy of data is lying across at least 3 nodes. The data is replicated at least thrice. And when my data is replicated thrice, say this hardware goes down or this node goes down, still I have 2 copies of my data, and when required to do the processing on this file, I can easily target node 5 or node 6 to do a data processing. Second thing, if you would have worked on systems where the load or they are high request there's always read logs on my data, read and write read logs on my data. When I'm reading from this file, another process also starts reading this file. There's a read log on this file, and the another process might have to wait. But when I replicate my data across nodes, another process could be spooled on this node and can read the data. So I am not only making my system reliable, but the read logs are again, when there's a high read request on my cluster, I can always handle them. So my system is reliable, efficient, economical, and scalable, and this is a specialty, or there's a heart of Hadoop, how Hadoop is created up at the back end, and by that virtue, the system is scalable, economical, efficient, and reliable. Any questions? Any doubts? Okay. So these are the few assumptions on which this system or framework is created up. Hardware will always fail. So 3 copies. Yes, Raja, 3 copies by default. Okay. So you are from data warehouse background. Little difficult to digest replicated data 3 times. I prefer 3 in normalization or 4 in normalization, and I am saying that I'm maintaining 3 copies. But yes, the world is changing up. Hardware, or hard disk is the cheapest thing available in the industry. The days are gone when my teacher used to say I have not denormalized my database. I am replicating my data. People are coming back to the sorry, I have not normalized my data. I'm replicating my data. That's not a good thing. The days are gone. At least 3 copies of your data are maintained to make your system reliable, to make your system efficient, to process your data very fast. How that helps in processing data very fast, I'll be explaining that part when I'll be talking about how the data processing happens in the system. Chris says, does the system process the same data in multiple nodes at the same times, or does it selects a specific node to process the file? Okay. So Chris, it process only the data on a single node. When I say process file F, the request might be going to node 1, node 6, or node 5. It will not be going to all the 3 nodes, because in that case I am unnecessarily wasting the CPU resources of 2 other nodes where I can just achieve it from node 5 or node 6. But in case node 5 is down in my cluster, my request will be going to node 1 or node 6, again based on different facts and figures. If node 1 is free, not doing any job, node 6 is free, and different factors are taken care of. I'll talk about them in some time. But the data processing happens only on one node at a time, not on 3 different nodes. Does that answer your question? So this practically what happens is the file itself is not copied. The file is divided into blocks, and those blocks are used for data processing. When I'll be talking about blocks, that will make more sense. I'll reiterate my answer when I'll be talking about blocks, and then it will give more insight how the processing happens, and how the data processing could be happening on 3 different nodes for a single file. But practically on for a particular block of data, the processing happens only on a single node. Okay, so hardware will always fail. No one can stop. Even the God can't stop from hardware from failing. And this is a major assumption before creating Hadoop. So I attended one of the conference. I keep on attending different conferences related to Hadoop and big data, and one of the guy gave a very interesting example. So he was working for Yahoo, and he was giving some conference related to big data, and he gave pretty good example. So he told that he one of his friend had a party planned over the Friday night. He was working in Yahoo. His friend was working in some other organization, and both of the organization were using the same data center to store same physical data center to store their data. But as data is replicated in Hadoop cluster, that data center gone down over the night, and his friend was spending whole of the weekend in the company to bring up the data center or the data which were the part of their data which were lying in that data center. But he did not even knew that the data center is down, and the data was taken up from the different data centers because data was three copies of data was available. So though other copies were also available in different data centers, and he didn't even knew till Monday morning that the data center was down over the weekend and everything was working as good as it was. So hardware will always fail. This is the first assumption on which SDFS as a file system is created up, and with the help of replication, the data I can very easily achieve it. Second, Hadoop as a system is created up with the assumption that you will be writing your data once and will be reading up many times, because in this system you will be pushing in petabytes, terabytes of data, and you would be doing some analytics, or you might be finding out some facts and figures on your data, or you will be getting a panoramic view of the data once you have dumped your data into this system. So the second most assumption in this system is you would be writing your data once and you would be reading the data many times. So all the how the read and writes happen in the system are created or architected in such a fashion that you would be reading it many times and writing it once. And the third foremost thing which we can't achieve is IO bottlenecks. I have already gave you an example in my previous slides. To read 1 terabyte of data, I required just to read, I required 45 minutes, and this and the maximum time over there is wasted in seeking the data. So data transfer and IOs are always a bottleneck, and the system is designed in such a fashion so that your IOs and data transfer can be reduced. Very large file systems, so your files would be big. You won't be storing smaller files, millions of smaller files in the system. Rather than you will be maintaining up a single file of say 10 petties or 10 TBs kind of thing. Why you won't be maintaining up smaller files? Because there's something called name node which maintains the metadata of the whole system. What is name node? Don't worry, we'll be talking about that in next few slides. So the problem happens with that guy. I'll talk about that problem in some time. uh, Commodity hardwares and move logic rather than data. So you always move the logic because logic is always of very small size and data is always enormous. So you'll move the logic and do the data processing locally on the nodes. So these are the few foremost assumptions on which Hadoop as a system, as a framework is created up. And it as a system caters each of these problems by the virtue of its DNA. Any doubts over here, other than why I should not be keeping up smaller files, millions of smaller files, and keep a big file? Other than that, any other questions? I'll talk about that in the next slide. Puneet says no. Okay. Okay. Raja also says no. Okay, so I'll assume no from others also. So from this slide, I'll talk about two new things. There's something called name node in the cluster. There's something called data nodes in the cluster. So if you remember one of my previous slides, I talked there's something called master node which maintains where is my data. So that guy is called name node in the cluster. And the green blocks downside are your real data nodes which do the data processing. So your data is really stored on your data nodes or these green blocks which I've displayed in the UI. And there's something called name node or the master or the monitor of the system which coordinates how the data processing happening in the system. And this guy just maintain the metadata of the system. And what is metadata? So this guy just maintain which data is lying where, which node has my which data. That's all it has. It never has your real data. So name node will never persist or store your real data. All your real data would be stored on your data nodes. Name node memory, name node processing is very, very precious. It will never It will never waste its memory or precious CPU in maintaining your data, processing your data. It will just monitor or maintain the cluster, and it will just maintain the metadata of your system. That metadata is nothing but I've got a big question. Just give me a minute to read that. Metadata is nothing but the data about the data, which node is having which data. So I have a question from Chris. Are there multiple name nodes, one per cluster, or does the number of name nodes depend on the number of second nodes? Okay. Okay. So Chris, the name node in the cluster is always one. There cannot be two name nodes in the cluster, like there cannot be two queen bees or in a beehive. There cannot be two name nodes in the cluster. Although there's something called secondary name node, which is a backup of name node. So in case name node goes down, secondary name node is gracefully up and the cluster is up. So if the name node goes down in Hadoop 1.0 architecture, the cluster was physically down, and someone has to up the secondary name node to make the cluster up. But in Hadoop 2.x architecture, or what we call yarn, this is gracefully handled, and with the help of Zookeeper, how that is done, I'll be talking about that part in some time. And secondary name node is nothing but a backup of your name node. So at a time, there's always one name node in the cluster, and there's something called secondary name node in the cluster, which is nothing but a backup of your name node. In case name node is down, secondary name node is gracefully made up in the cluster, and your cluster is up and running as it was, without any blockage to your users or clients. And the cluster side could be anything, but the name node would always be one. You can keep on adding these green nodes which are data nodes displayed over here. You can keep on adding them, and name node will just maintain the metadata about your data, what is stored in your data nodes. Does that make sense? Okay, so I got one more question from Raja. Here I could not see the connection relation between. Oh, okay. Okay, so Raja, in this slide, this slide, I don't want to come up with a complex thing, how your data, how the architecture looks like. But in this slide, I just want you to remember there's something called name node, there's something called data node, there's something called secondary name node. And name node stores your metadata, and data node stores your real data. If you remember that part, that is much more than sufficient for this slide. How the interaction happens between them, I'll be coming on that part slowly and slowly. I want to digest the thing slowly and slowly, so that I'll be keep on adding the things in next slides. So if in this slide you get to know there's something called name node, there's something called data secondary name node, there's something called data nodes. That's much more than sufficient for this slide. How the system looks like, I'll be coming to that part. How it reads, how it writes, I'll be covering all those things. How it reads, how it writes, I will be covering all those things. How the read happens, I'll be covering all these things. But I'll be coming to them slowly and slowly, so that you can digest the things. No, Chris, there's no limit on the data nodes. You can keep on adding the data nodes, but in 1.x architecture, there was a limit to horizontal scaling. But with the help of yarn architecture, that is again been overcame, and there's no limit to the data nodes which you want to add to your cluster. There's a little difference between 1.s and 2.s architecture. In the basic slide, I'll be only covering the 1.s architecture, but once you understand the 1.x architecture, I'll explain you what is the difference between 1.x and 2.x architecture, or what we call yarn. So that I'll be covering on, but later on, once you understand how the 1.x works up. And yeah, there's no limit. Okay, so Raja says, all right. Okay, so there's a distributed file system. My files are distributed across the nodes. Your data is distributed across the nodes. Okay, I'll come to this slide in a minute. Intelligent clients, file. I'll come to this slide in a minute. Okay. Okay. Let me complete the slide only. That slide is little later on. So your data, when I was saying your file is practically broken up into smaller blocks, and it's really the blocks which are replicated in the cluster. So say this is a file F. This is broken up into 64 MB size blocks, and these blocks are really distributed in my cluster. So there's a copy, 3 copies of these blocks are created up, which are replicated in the cluster. I'll show you that in this slide. I talked about write once, read many times. Client can, okay. So appends or updates are not possible in this file system. If you have to update the data, that is not possible in the Hadoop as a file system. It's very easy to delete the data, or I would say it's very fast to delete the data and rewrite the data rather than update the data in the Hadoop file system. And intelligent clients, because name node knows where your data is lying. So whenever clients want to read some data, it just requests the file name. Their name node returns where the data is lying, and the client really reads the data from there. So that's how we call intelligent clients. Okay. So when I would be using a Hadoop, when I'll be using my traditional or traditional databases or traditional systems. So this is a slide which talks about that. The x-axis is the data size. The y-axis is the complexity or time which your query takes to process up. And you can see there's an intersection happening over here. Don't I won't commit these are the figures. That will again depend on the complexity, your system, your architecture, your data. But there is always an intersection which happens later on the x-axis, from where you would be moving on, from your traditional system to the Hadoop. And prior to that, your traditional systems are much faster as compared to Hadoop. So you can see over here, my traditional systems are returning my data in microseconds, but Hadoop is returning your data in seconds. But after this point, yeah, the graph is almost horizontal in the Hadoop, but graph has gone vertical in your traditional file system or traditional databases. So you have to look at this intersection point precisely in your project, precisely at your workplace when you have to move to Hadoop or related systems. And prior to that, your traditional systems are much better and much good as compared to Hadoop. So when your data is less, when your complexity to process the data is less, and that can be handled with vertical scaling, you're good enough with your traditional systems. But when your data is high, you can't live or survive with the vertical scaling, then you have to move on to Hadoop. I'll come back to this slide later on also, but any questions on this slide? No, Shelly says no. Okay. Okay. So, sorry, Chris says why? Sorry, Chris, I did not got your question. Why? Can you please uh, type type the whole question? So before you type up, I'll read the question, but let me let me talk. So these are the different flavors of Hadoop or Apache Hadoop which are available in the market. We'll be looking at Hortonworks, but they are different flavors. All of them are very much similar with a few tweaks here and there. But the code which you'll be writing up or the way you would be looking up or interacting with the Hortonworks is very much similar. Either you interact with Cloudera, either you interact with Mapr. It's almost very much similar. Either you use Amazon AWS, either you use proprietary things like Pivotal HD, IBM, Big Data. So these are proprietary. These are open source. And I prefer Hortonworks because that is 100% open source. Cloudera has some of the proprietary things like Impala. Mapr is a little bit old. They have recently moved on to 2.x. However, the word has moved on to 2.4 now. So Hortonworks is very much aligned to the open source, and will be using Hortonworks flavor to do all our big data processing and to run all our program. But the way you'll be interacting with the Hortonworks system or Hortonworks flavor of big data, same way you will be interacting of with any other flavors. So these are the different flavors available in the market, which are implementing the Apache version of Hadoop. So if you have any questions, do let me know. By the time I'll just read the question from Chris. It is network delay that makes the relational database faster. Okay, okay. That's a very good question. So I wanted you people to ask this question on this slide, and that's the reason I said I'll be coming back to this slide because you have not asked this question. So Chris has a pretty interesting question. Can anyone guess why Hadoop is not good for lesser data? Any guesses from anyone? That's a very good question. And I wanted you to ask this question, and that's the reason I really said I'll be coming back to this question because I knew this question would be asked. Any guesses from anyone? Padmini, Puneet, Sally, Raja? Okay. Okay, so you'll not be able to get the answer fully over here, but let me try to explain. But you will understand when I'll be talking about Hadoop concept. So what happens up at the backend is when you do a data processing, there's an enormous uh, how to explain that right now. So basically what happens is at the backend, there's an enormous code or enormous processing happens at the backend. This is a MapReduce code which emerges at the backend. There's little data transfer over the network. There's a lot of bookkeeping activity which happens on task tracker and job trackers, and there's a lot of activity which happens at the backend to do your real data processing. Because when I'm processing my data across the network, there's a lot of bookkeeping activity which is required to maintain all the processing which are running in my cluster. So if I have to process the data in this cluster, some process might be running over here, some might be running over here, some might be running over here, some might be running over here, and then I have to coordinate all of them. I have to, say I have ran a job. Select employee count from table employee where my data is lying in these nodes. So each node I'll be doing a sum, but later on that sum will again need to be summed up to give a real figure to you. So a lot of activity which happens at the back end. And to maintain and do all those bookkeeping activities, there's an overhead in the system, and that overhead leads to this time. But that times overcome when your data increases, that overhead is always consistent or almost consistent, and that makes it much faster when your data size grows. Does that make sense, Chris? Not fully, if not fully, at least somewhat. Am I audible? Yeah, overhead is in the orchestration and doing all the bookkeeping activity which happens at the backend. So that overhead makes your Hadoop costlier, or should not be used if your data size or processing is good enough with your traditional systems. Okay, so what happens at the backend? Let's look at it. So when I was saying the data is divided into blocks, let's say this is a file so by default the block size 64 MB, but everything is configurable in this word. And in Hadoop 2.x, that is the version 2 or YARN architecture of Hadoop, that size is increased to 128 MB. So always your data, whichever you put into the system, is divided into blocks, and these blocks are distributed in the cluster. So what I'm showing on the left hand side is one data center. There could be n number of data centers in your cluster, and these are the racks in my data center. Everyone understand what is a data center and what are racks before I go before I show this slide? Please bring me right away if you don't understand what is a data center, what is rack, what is node. Okay, Raju says yes. Padmini says no. Puneet says rack. Okay, okay. Anyone want to explain what is data center, what is rack? Shally, this time, do you want to explain? Raja, do you want to explain?
This is Sally. So a rack is a place that you would have a bunch of servers. So you would have, they would be on different power sources. You take a look at it, and it's, you've got a bunch of different servers, could be a bunch of different databases all in one location. And so if you have different racks, then you can distribute it so that if there was a power outage or something wrong with that rack, that you have replication to a different rack. And so if you were replicating on disk 1 and 2 and that something happened with that rack, then you'd lose it. But if it was on rack 1 and 6, then you wouldn't, because perhaps rack 2 would be okay.
Yes. So there are different racks, and each rack would be having a servers or bunch of servers, and the servers are there could be different racks in a data center, and data centers are geographically distributed servers. So there could be one data center of a company in Los Angeles, the other data center could be in New Jersey. So there could be a number of data centers where data would be stored up to limit the geographical factors, and inside our data center your servers would be distributed in the racks to limit the limitations of rack or some infrastructure going down. Yes, that's a perfect answer.
It's pretty early in the morning over here.
Okay.
I'm still drinking coffee.
So actually, the people are from different geography, so it is always difficult to maintain time also.
Oh no, it's fine.
So you can enjoy a coffee. In this example, I'm just assuming there's only one data center in my cloud, and I'm putting my data. So whenever you push in your file into your system, your file is always divided into blocks. Your file is always divided into blocks, and these are the real blocks which are stored into your cluster. And the disk 1 to disk 12, which are displayed over here, are the nodes which I was showing previously, or which I was telling previously. So these are your real data nodes in the cluster, and the name node is sitting somewhere else. Don't worry about the name node at this point of time. So when I have to put these blocks in my cluster, these blocks are really replicated in my cluster. So let's try to put these blocks into the cluster. So I'm trying to put the first block of my file. So file size is somewhat it is divided into 5 blocks over here. On the right hand side you can see. So the first copy of the first block has been pushed into disk 1, and the second copy and the third copy of that block has gone to disk 6 and disk 7. Any guesses? Anyone want to give a guess why it has been moved to disk 6 and disk 7 and not on the same rack, that is rack 1? Puneet says backup. Sally answered already. Yes, Sally answered already. So, so basically, if the rack 1 goes down, at least I have my copy of my data at rack 2. So a whole rack going down, the probability of whole rack going down is pretty high as compared to two different racks in my data center going down at the same time. And similarly, a same disk going down in a single rack is, the probability of that is again very high as compared to two disks going down in the same rack. It's again a lesser probability. So the data is copied on disk 1 as well as disk 6 and disk 7. And this is where I'm segregating or reducing the risk of reliability. I'm making my system reliable as much as possible. Now my second question is, which was not answered by Sally. Why I have not copied the third copy, that is what is copied to disk 7 to rack third? Why it's copied to same rack 2? Does that use determine whether to block the, does the user Chris, no, user does not determine where the blocks are copied. However, you can write your own writing strategy, how you want to decide which nodes to be given priority to where your data would be copied up. That is configurable thing. You can configure, everything is configurable in this world, so you can configure that part, but you don't define or describe where that data would be copied up. Everything is taken care by the name node. So Puneet says distance over the network. Yeah, Puneet, I buy your question answer partially, but give me a detailed answer. Reduce overhead of read. Raja says reduce overhead of read. I am not able to get your how that will reduce overhead of read. Basically, I am copying the same block, that is block 1 thrice. So I'm not sure how you're saying I will be reducing the overhead of read. Puneet was giving a little bit, correct guess, but I did not. I will not buy your answer fully if you give me a. Yes, so that. So Raja says, but the rack is same. Yeah, that's my question is, why it's not copied to third rack. Okay, let me answer it. What happens is when your data is copied or your data is pushed onto the system. If I go back to the slide. Whenever I have to read or write some data, I just request the name node where I can read it or where to write it. And client as a person really sends a write request. So your data is transferred over the network. So when this block is copied over here, another copy would be sent from this disk to this disk. And then a copy or network transfer will happen from this disk to this disk. So network transfer or data transfer over a network in a rack is cheaper as compared to data transfer across rack. And to reduce that network bandwidth or network cost, the third copy is safely placed in the same rack where my previous copy was placed or the second copy is placed. But however, the second and third copies are always placed in a different rack to reduce or to increase the reliability in my system, to reduce the risk and increase the reliability in my system. But to save the network cost, I copy the third copy in the same rack where my second copy was copied. So Chris, not only to enhance the read performance, but to use the processing power of the nodes. So now say I have a process. There are two users interacting my system. One says select employee count from employee table, and this file is say employee file only. And another user comes up, fires another query. So one process might be spooled on disk 7 to do a data processing. Second process might be spooled over here to do a data processing. So I'm using the CPU on two nodes, not only to read, but to process the data also. So that not only do a enhance of read performance, but that also uses the CPU or the resources across my cluster, and definitely increase the reliability. does that make sense? So now I have to copy the block 2. So any guesses where it go? So let's say the first copy goes to disk 6. Can anyone guess where the second and the third copy will go? I need a correct answer. I've already explained the logic. I need a correct answer from everyone where the second and third copy of block 2 will go. Okay. You can copy the same block. So Chris has a caution. Chris, I'll read your caution. Give me a minute. Padmini says if rec 7, if 7 1 rec. Sally says rec 3. Puni says first rec. Padmini says 7, 1. I did not got a correct answer from anyone till now. A perfectly correct answer from anyone till now. Raja says disk 11, 12. No, still not a correct answer. Chris says the same disks. No. Any more guesses? Okay. Okay, no guesses. So the correct answer is it will not go to rack 2. It can go to any other disk on rack 1 or rack 3. So it will reduce the risk of rack failure, but copying it on rack 1 or rack 3, that's again, the name node will decide where to copy it, but it will not be copied on this rack 2. It can be copied to any other nodes on rack 1 and rack 3. So it will be copied to any two nodes across any other racks, but not rack 2. So it's copied to disk 2 and disk 3. Now let's try to put the rack block 3. So it's been copied to the disk 8. Now I hope everyone can guess where it go. It can go to any other rack, but not rack 2. So other copies would go to any other rack, but not rack 2. So does that make sense? So it gone to rack 3. Okay, so I had few questions. I'll just read them. So Padmani says if block 2 is resistant to block, if block 2 is resistant to block 2, 1, it will be easy. Okay. Okay. So Padmani had a pretty good question. I'll just come to that part. Give me a minute. What is the max size of the block? So Puneet says, what is the max size of the block? Puneet, there's no max size of the block. Although there's a default size of 64 MB and you can always change them. Everything is configurable in this word. So you can change it to anything. And 2.x is 124 MB. And you can make it anything, but cannot. It can be of any size. It can be even the size of greater than the size of a disk also. Okay, so Padmani has a pretty interesting question. If block 2 is resistant to block to 1, it would be easy for processing. Anyone want to comment on this before I say anything? Any guesses from anyone? So I keep on asking questions to you. I keep on motivating you to answer so that you are interacting also, and that makes you not to sleep with my boring lesson. Okay, so Chris, I'll repeat the question. So Padmini says, if I copy the block 2 next on the disk 1 or next to disk 1, it will be easier for me to read the whole file. Okay, so let me answer it. So what happens up is, Padmini, in the cluster, although you can see the physically nodes are next to each other, but when I'm doing a real data processing, my process is running across the cluster. And when my process is running across the cluster, it does not matter to me where my block is lying. All I have to know is where my block is lying. That's all. what is the physical location of a block does not really matters to me when I'm doing the data processing, because if I spool a process over here and next process over here to read the same file, or P1 over here, P2 over here to read the same file, and P3 over here to read the same file, that does not matters to me, because all I'm transferring is the logic to process the data. So in
Okay,
that
so
case,
my understanding,
yeah, go ahead.
sorry about it.
Yeah, go
So
ahead. Go
my
ahead.
understanding is like instead of going from like the block for the file block 1 to block 2, it always like go to like from the name node to the file block 1, and then from the name node to the file block 2. Is that right?
Okay, no. Name node never waste its precious resources to read anything, to process anything. Name node will just guide the client where the data is. Then the client will really send the logic to those data nodes, and the data processing happens over there. And when I have to read something or write something, I as a client just send a request to those data nodes which name node has told me where to copy them.
Okay, so the way the index pointer lies, like where this block 1 and block 2, block 3 lies, how you know
So
about it?
how you know? So that's what I said in the previous slide. So if you look over here, what I said is name node just maintain the metadata. So when I as a client says I have to write this file which has 5 blocks, I'll just request name node. I have this file need to be written. It has 5 blocks. I'll interact with the name node. Name node will tell go and write block 1 on disk 1, disk 6, and disk 7. Go on and write block 2 on disk 2, disk 3, and disk 5, and so on. I as a client now has the responsibility to do give a write operation. So what happens over here?
Okay,
So let me just a minute. Let me. Uh, okay. So what will happen is I as a client will ask name node where to write the block. Name node will return me, hey guy, go and write it over the disk 1, disk 6, and disk 7. I will give a write signal to disk 1. Disk 1 give a write signal to disk 6. Disk 6 will give a write signal to disk 7. It will send an acknowledgement to this. This will send an acknowledgement to disk 1. That will send an acknowledgement to client, and client will send a complete acknowledgement to name node. So now name node has a metadata because name node is the only person who told me where my data would be copied. So name node has the metadata where my blocks are lying. And next time when I have to read it, I'll just ask name node, I have to read the file, tell me where to read it.
okay.
So I'll be coming to this slide
Thank you.
again in future.
Yeah,
But does that answer your question?
yeah, thank you.
Sure. Any other questions over here on this slide? So, okay, Puneet has a question. Are all yes, Puneet, all blocks are of same size. So you configure the cluster with the block size, and the blocks are always of the same size. So I think we are already running up the time. Any other questions anyone has on this slide? Okay, I assume no questions. Okay, so we'll talk about the SDFS architecture tomorrow. Otherwise, we'll be running a lot of time. So we'll wind up today. So I'll unmute everyone, and I'll just request all of you to just tell your feedback. Now, what do you think? How it's going up? If you want any changes, we can definitely try that. And any comments which you have. So I'll unmute everyone, and those who can't unmute themselves like Chris, they can just type it on the chat window. I'll read it for you. So I've unmuted everyone. So now you can just right click and unmute yourself.
This is Sally. It's going good.
Okay.
Appreciate it.
Okay. So does that meet your expectation? What you were looking for? We'll be looking onto SDFS in detail tomorrow. But is this is what you were looking for? Any comments? Anything?
No, it's good. We'll try to be more interactive. It's for me it's 6 a.m. to 8 a.m. So.
Okay. So I request you to sleep today a little early and wake up early.
For me also it's good. Like the phase of the thing is going on, like not very too fast, not too low, like it's going on a normal thing. It should be good for me.
Sure, thank you. So yeah, definitely if it's going fast, do let me know. I'll try to slow it down. So that's the most critical thing. If it goes fast, then you won't be able to get the things, and then my objective is not reached. Puneet says, yeah, Chris, it will be same time tomorrow, 8 to 10 CST. I'm not sure. 6 to 8 PST. You can convert to corresponding CST. Raja, Puneet, do you want to say something?
Yeah. It's been really nice, and I'm enjoying these lectures.
Okay, sure. Thank you. Raja, any comments? Anything? Okay, sure. So Raja and Chris are not able to mute. So from tomorrow, I think you just try to use the GoToMeeting app if you're using iPad or laptop or phones, and there it will be easier for you. And if you're using laptop, just download the GoToMeeting software, and that will be make it much beneficial for you to unmute and to flip on here and there. And when we'll be doing a real practical session, at that time it will be easier for you to share your screens. So just download the app or the software on your laptops and desktop. So that will be easier for you to unmute yourself and use the audio of the app or the software. So Raja said it was good. Okay, cool. Then I'll assume it's going good with everyone, and let's meet tomorrow at the same time. And we'll be looking into how your data is really stored, how your data is processed in this cluster, and that might answer the doubts which you had today. That will really clear up your doubts in detail tomorrow. Chris also said it was good. Sure. Thanks everyone for your comments, and let's meet tomorrow same time. And thanks for joining us. And I hope you will enjoy the whole session. And if you miss any class, just drop an email to the admin team, and they will help you up with the record sessions. Yeah, okay. Yeah. So Chris also raised a good point. So Chris, regarding the presentations and the software, so I request everyone to just quickly type in your Gmail IDs to me. I'll be sharing all the PPTs to you on the Google Drive, and you can download it from there. And I'll be also sharing all the softwares. You can download them. How to install them, don't worry about that. We'll be talking about that thing in the class. So if you just quickly type in your Gmail IDs, that will be great help, so that I'll be sharing you the softwares and the PPTs. So PPTs I'll be sharing after each and every logical completion of the session. So once I complete the whole PPT, I'll be sharing up. Before that, I'll be not sharing up, because in that case, the question which I'm asking will not be interactive, because you might flip flop to next PPT. So I'll not be sharing the PPTs till I cover up the whole PPT, but I'll be keep on sharing the PPTs and the softwares to you. So I request everyone to just type in their Gmail IDs, so that I can share the stuff with you. Okay, why? So I got why Raja Reddy Gmail. Okay. I request others also to just quickly type it on the chat window. So Chris, I got it. QAISZAR.gmail. Padmini, I got it. Okay, Shelly Hop at Gmail. Sure. Okay. Okay, sure. Thank you. Thanks everyone, and thanks a lot for joining us. Let's meet tomorrow same time. Good morning, good afternoon, and good night.